So you're telling me Steve Jobs invented Ethernet?
I'm telling you that Steve Jobs made the comment to Bob Metcalfe and co. that the SheepNet stuff was good, but he would really like to have it on the voice cabling. And so I would say he prompted what we think of Ethernet today.
What advice would you give yourself if you were 18 or 22 years old? So if you were talking to your younger self, what advice would you give yourself?
Drink less beer.
I like that. Hey everyone, it's David Bombal back with a very special guest from Cisco. Peter, introduce yourself, please.
So thanks, David. I'm not sure I'm quite that special, but I'll take the compliment. So my name is Peter Jones. I work for Cisco. My day job is at Cisco. I'm a distinguished engineer in the hardware side of the house. I come from Australia originally, so that's where you can tell the accent is from.
Yep.
And we tend to be pretty blunt and direct.
Good.
And I also, the other hat I wear a lot is I chair the Ethernet Alliance, which gives me this great stage to talk about Ethernet because clearly as part of Cisco, right, I'm somewhat constrained in what I say, but being part of the Ethernet Alliance, I can go and evangelize about Ethernet all day and all night. And the other thing I do is to do a bunch of Ethernet standards. The thing about me I think is interesting is that I've become a specialist generalist.
Yeah.
Because coming from Australia, you tend to have a lot of that. And I think it's to do actually with the colonization, because originally when you got out to Australia, if you didn't have anything, it was 6 months to get it. So you became pretty adept at reusing what you have.
Yeah.
So I tend to be good at communicating across groups and between specialties. And that sort of comes in handy when I do Ethernet standard stuff. Because one thing about the Ethernet standards, the 802.3 organization, is the rules for getting anything done. You need 75% of the group to agree, and everyone's individual vote. So given that 75% with your customers, your competitors, your suppliers all in the room, unless you can talk across groups, it doesn't work very well. So thank you for having me on, because I do enjoy this, and hopefully we'll get time to talk about where Ethernet came from, where it's going to, and I guess most importantly, why people should care.
Yeah, I wanted to ask you. So, here's an Ethernet cable. So, in today's world, why would I care about Ethernet? Is it important to know about it?
Yeah, probably, right? If you think about it, every piece of traffic across the internet goes across Ethernet. And yes, you might connect via wireless, but behind your wireless is an access point or a base station, and behind that is a wire. So everywhere from inside your house to your ISP, back to the telcos, if it's over 5G, it's back to the base stations, back to the data center, and then inside the data center, right, they're not using a Wi-Fi to get stuff around. So inside the DCs, they're laying down anywhere, the edge links have migrated from 10 to 25 to 50, and will probably go to 100 after that. The backbone links in the DC are probably at 400 going to 800 or 1.6.
That gigabits you're talking about, yeah?
Yes, 800 gigabits to 1.6 tera. Every bit of traffic in the world, to a large extent, goes across Ethernet. It's like the electricity cables, right, in places where they have it buried, right? It's there, but you don't think about it. But if it wasn't there or you had a problem, right, there is no power. So I tend to think about, network access is sort of like oxygen. I used to think it was like water, but you notice when the water goes away.
Yeah.
With oxygen, you can't see it. You just expect it's there. And so, the difference between, you and I are both not the youngest guys in the world.
Unfortunately.
And so when when I went up and went to college, right, the internet was this very tiny thing. And if your computer didn't work for a while, it didn't matter. In fact, I didn't actually own a computer until 2000. I graduated college in 84. There's this been huge shift in the technology. So whereas when we grew up, right, we knew there were computers, right, we'd seen them, but now everyone uses them every day, and it's just something that everyone expects to work.
Yeah.
Now, behind that, everyone expects to work is a huge amount of work. But if we do our job properly, no one ever thinks about us. I consider us to some extent honorable plumbers, right? Just get stuff done, because our job is to let everyone else either live their life or do the work, right? And if we do that, then we've done our job.
Yeah, I like that analogy. It's exactly like you say. If you just assume that when you hit a switch, the lights are going to go on. When you connect, turn your phone on, you're going to get internet access, and it's the end of the world when it's not.
And if you don't, you shake it, right, and you look at it and you swear and you try and wave it around, but you have no idea which of these things work. It's like reading chicken entrails. It's like, oh my God, I hope this works, because if it doesn't, I have no idea what's behind it. Or maybe another analogy: if you go back in time, when I was a lad, you could look under a car bonnet and you could fix most things. You could understand them, right? Most people look under it today. You got no hope of figuring out what's going on there, but it's still easy to operate. In fact, it's probably easy to operate. So I think the big thing that the networking industry has succeeded very well is building a hugely complex system that no one needs to know about.
Yeah, I mean, it's interesting because, like, just going back in history, I remember in the old days we had like all kinds of connections, like serial connections, etc., showing our age. But like now that's kind of been replaced in a big way by Ethernet. Is that right?
To a large extent, if you looked at certainly in the corporate IT business, that's all Ethernet. Now, if you go and look at operational technology in industrial and building automation, and even in cars to a large extent, there's an awful lot of serial out there. So the OT business as a whole, right? IT is providing networking for people who sit down nicely and have good jobs. OT is control systems. So
what is OT? Sorry, just for everyone.
So operational technology.
Okay.
So there's information technology and operational technology. I mean, if you think about a building, there'll be one IT network. There might be 10 OT networks. There'll be one for the doors. There'll be another one for the HVAC. There'll be another one for emergency lighting. There'll be another one for this. So those networks today are mostly still serial.
When I met you at Cisco Live, it's like time flies. I mean, you and I had this conversation about Ethernet going into those networks. Is that sort of where you see it going? I mean, I want to talk a bit about the history. I've got some really old Ethernet here on my desk, but do you see Ethernet not just taking over like we said, information technology type links, but also going into those networks?
Absolutely. I mean, the trick is that the OT business tends to be fairly conservative. Now, for instance, if you're running an oil and gas plant, there's pretty good reasons to be conservative. But what you're seeing at the minute is that the OT guys are come to the stage where they have to move on. They're looking for things like cloud connected and preemptive maintenance and all this other stuff. And right now there's this layer at the edge, the field bus layer, which stops them making progress. Now, the problem has been so far, I think that the IT world tends to be fairly arrogant.
Yep.
So we tend to want people to come to us, and that doesn't really work. You've got to go to people where people are. So if I show up and talk to a guy who's been designing, industrial control networks for 30 years and say, "Hi, I'm from IT and I'm here to help," and you got it wrong for the last 30 years, I don't get very far.
No.
So I think what's happening at the minute is Ethernet used to be a pretty it was a straight line. It was 10 times the speed for 3 times the price. But I think what we're doing more recently is we're doing what's technically called speciation, which is where you fan out from the major branch of life to fill in all in the middle. And I think OT really coming up with networking technologies that work for them is sort of our next thing to do, because I think there is a huge amount both for business to be made and also for benefit to be given. So yes, that's going to happen, but these guys tend to be slower, right? And again, if you're building an oil and gas plant or you're building a coal-fired power plant or something else, there's reason to be pretty conservative.
And what type of cabling will they use? Is it like this type of cabling, or what type of cabling will they look at using in those environments?
So what's normally used at the minute is it will be serial cabling. So it'll be something that looks vaguely like this. This is basically 18 gauge single pair, shielded. And so this is commonly called 18.2. So there's an awful lot of this that's scattered around buildings and also in factories. And so again, this is what they would be running current protocols like BACnet or DeviceNet IP on, or maybe even a 4 to 20 milliamp connection. And so part of the goal to go to where they are is to basically, ideally, to let them change without replacing their cabling plant, or at least change without restructuring it. So if I'm used to, for instance, running a serial cable for 800 meters, and I come and tell you, look, you've got to go to Ethernet, but it's 100 meters most, and so you're going to have to put 3 switches in the way, right? That's not credible. You want to think about if a industrial facility might have a 30 to 50 year lifespan. I really don't want to make them recable. And as a friend of mine says in the cabling business, the last best use for an existing cable is to pull another one through the new conduit. What you think about is these people have a design pattern they work off, and we really want to let them retain that design pattern. Otherwise, we just make it hard.
So the Ethernet that they're using is not going to be 100 meters. The Ethernet that you're talking about, is it got like a name or?
Yeah, this one. So this one is 10 base T1L. So it's a standard that came out 82.3 CG in 2019. So it's 10 megabits a second over a kilometer.
Over a kilometer, did you say? Yeah.
Yes, over a kilometer, because that's sort of the sweet spot of the technologies we're replacing. So the first people who are really chasing after this are the process control guys. And so this is the people who tend to be very concerned about intrinsically safe, because if they're running oil and gas or similar, their network is working in places where a spark causes an explosion.
So if I was like thinking about getting into networking, would you see this as a growth area, something that there's a lot of opportunity in that sort of area as well as like traditional networking?
So I absolutely think that there is a huge opportunity for people to help factories and building automation move from where they are today to where they need to be, because they have to make that move. And a lot of the people in those markets look more like me, right? They're getting old, they're wanting to retire. So there is this I think there's this place coming for people who can learn to understand the processes required in OT, how things are actually produced, right? How HVAC systems work, and combining that with networking. So yeah, I think that's going to be really important. I mean, my eventual goal would be a single network for a facility. So if I looked at a factory today, they'll have a small data center network somewhere. They'll have an IT network. Outside of that, they have effectively industrial automation and building automation. And ultimately, we want that all to use a common infrastructure. Now, you can say, is that just because you want to sell more Cisco switches? Well, I do want to sell more Cisco switches. But ultimately, that only makes sense if we can help people do their job better. So if we can get rid of a whole lot of duplicate infrastructure, we can also help the people do things because, as I said, lots of people in that business today sort of look like me, and you might get an alarm from a large piece of equipment, and they'll send the guy out who looks like me. He's going to whack it with a hammer. He'll listen to it, and he'll tell you what was wrong. Someone at a college is going to want to log into that with their smartphone. So we have a big gap to fill. And I think there's a lot of opportunity to do it.
Yeah, the way I look at this is, do you see this as like another, I hate to use an old analogy, but I remember in the many years ago, I was getting into voice over IP, and we had like the traditional telephones networks, and then we had the networks, and then they kind of became the same. And network guys just took over those jobs. And I'm not sure that's what's going to happen, but you see this kind of the same history repeating itself where Ethernet takes that over as well?
To a large extent, yes. So if you go back to the early 90s, right, there was a vast quantity of different types of protocols and interfaces and transmission media. And I worked on a bunch of them. I have a word cloud somewhere, right, with being at SNA, being at Burroughs, being X25, etc. And all that stuff is really condensed down to Ethernet. And I think the reason is because once we got there, it actually enabled innovation. Originally, everyone thought their own was special. And what we've done is we've decided on like the bottom layers being Ethernet, Wi-Fi more lately, and the IP stack. And so I think we're going to go the same path. And so, yeah, it is going to be a bit like the PBX world. And I think Cisco shipped the first IP phone in about 98, right? And if you'd invested a lot of money in Nortel at that stage, it would be sad. Now, I think the transition is going to take longer because the phone system is still owned by people closer to IT than to OT. But I think this change has got to come through. A lot of people describe this as Industry 4.0. And what they're really talking about is what they consider the fourth industrial revolution. And I have slides about this somewhere, but it sort of comes back to the era of the connected machine and really a larger system. So that all being said, yeah, I think there's going to be a lot of work. Now, I think your ideal people understand networking and also the other field, right? If you just have someone come in who just understands networking and tries to tell someone what to do, that's a bad thing. So people who can understand both sides of the house, that I think is where the value becomes. So it's sort of opening the field up a little bit. You could approach it from the networking side and learn something about OT. You could approach it from the OT side and learn something about networking.
I've had quite a few comments on YouTube where guys have come from like HVAC environments and they're trying to get into networking. Yep. So this might be like a great way for them who wants to get more into IT, get a better job, that kind of thing. This is a great sort of middle ground. Is that right?
I think so. I wouldn't say it's get into IT. I'd actually say in an ideal world, I mean, it's a bit like the topic of automation, right? When automation and DevOps, NetOps became common, a whole lot of the old-time networking people said, oh my God, I'm going to lose my job. But the reality is done right, it lets you do your job, lets you do more of the things you like. Yeah. So it becomes a force multiplier. So I think the way for the HVAC guys to go is not necessarily let me go and become a standard IT guy, but let me help take my business into the future.
Do you see Cisco like, and I mean, this is your own personal opinion, not Cisco or any big.
I do not speak for Cisco. No, on the various hats I wear, this is the Peter Jones hat.
So, I mean, do you if you put yourself in someone's like shoes today, do you see that it's if I had an opportunity, would you still see like networking as a big field, and this just like making it even bigger and more opportunities?
Yes. If you think about it. So if you went, for instance, if you're one of the people who used to work in an office like I used to, imagine you're in an office of a normal, reasonable company, high-tech company. If you look up at the ceiling, you'll see a whole lot of things. Yeah. One or two of them will be connected to the IT network. You'll see a couple of access points. Everything else is on various OT networks. So it's a bit like if you think back to the early 90s when the internet was starting to grow, right? Just think through the transition that's been from there. My guess is we have more than that much infrastructure to upgrade in the OT side of the house. Now, the other thing about it is a lot of that infrastructure is highly valuable and has to be highly secure and highly available. It's one thing if you break the network in your building, right, and the boss can't get internet for a while, you tell them all to go out to lunch. If you turn off the network in something like a either an aluminum or aluminium smelter, depending on where you come from, right, it will freeze. And so the requirements for the OT world are much higher, which I think means fundamentally the value of the people working in there becomes higher. I mean, I think there's a huge... So my first job out of college was actually working on an iron ore mine. Hang on, let me grab something. So this is a bit of hematite. So this is about 78% iron or so.
Yeah.
So this is from the mine where I first started working. At the time I was there, they shipped 100 million ton. I don't know how much they've gone through now. So those guys are starting to do things like they're running autonomous trucks. But if you think about that infrastructure, if that stops, that's millions to hundreds of millions of dollars a day. And so the requirement, and you can't, it's not like a DC, because in a DC, if something goes wrong, right, it all spins up at some other DC. If my mine site goes down, there isn't another mine site to spin it up to.
So this is like a trend. This trend is like IoT, Internet of Things types devices,
okay, so
like all this stuff's kind of moving together. Is that right?
Internet of Things is a really bad name, right?
Yep.
It could have been the Internet of everything else. So IoT has become almost meaningless. So I tend to call operational technology.
Okay.
So these are the things that control the profit-making assets of a business. I'm not talking connected cows or connected fridges or connected toasters. They're very cool things. That's just not me. I'm talking about what is it that makes the factory run, right? If it's regardless of whether it's producing Coke or gas, right? What is it that makes that run? How to make it run efficiently? And those are the things that underscore economic productivity and people's jobs for a lot of the world.
I mean, it's interesting because, when we were speaking about this, it sort of like a light bulb went on for me that if companies have to upgrade all this stuff like they did with the VoIP technologies years ago, there are massive opportunities for someone who gets into this early. So, Peter, is there a standard? I think you said there's a standard, and sort of like 2022 at the moment. When do you think this will start ramping up?
So it is already ramping up. So if you go take a look at what's being installed in factories today, I think probably being installed today what they call industrial Ethernet, which is close to a standard Ethernet but with a few tweaks. So like an industrial Ethernet switch will be DIN rail mounted. It'll be more resistant to dust. It'll be locally powered. Cisco right now I think is the leading vendor and growing.
Yeah.
And so that sales is doing pretty well. I have to remember the numbers, but there's still a lot of field bus going in, which is the old serial stuff. But think about the lifetime of what's out there. So even if you look at a new Ethernet, let's consider the enterprise. We would think about maybe refreshing network infrastructure in enterprise every 7 years or so. But building lifespan is probably 30 to 40, and you don't get to change the cabling unless you gut the building. Okay, so lifespan for industrial facilities is even longer. So the install base is huge. So this is a whole bunch of places that really want to adopt new technology but can't because of that physical infrastructure. So if we can enable that all moves faster. So it's not that there's the technology I'm working for is a way to get Ethernet to places easier.
Yeah.
Right. So if people have seen the value of it, it's not a question of, hey, go and take 10 megabit Ethernet over, because that solves your problem. This is I've got a set of benefits, and 10-base T1L lets you get it to more places easier, right? It's closer to what people need. So yeah, I think there's a huge opportunity for people who understand networking and also understand some of these other disciplines, because often the networking people, you've seen this with phones.
Yep.
The networking people come in and talk, okay, here's my ping, and the phone people come and say, what's your MOS score? So the ability to talk across those boundaries is really important. And I think that fundamentally controls how fast this stuff gets adopted.
Peter, so you're the chair of the Ethernet Alliance. Can you explain what that is, and how does that work with like the IEEE and other standards bodies? Kind of what is it about?
Most people actually know what the Wi-Fi Alliance is because everyone actually has Wi-Fi certification. So the Ethernet Alliance is a little different, but we're a vendor alliance, and the goal in general is to sit between the standards groups and the market.
Yeah.
Right. So we want to be able to explain the standards groups to people out there in the market and explain the market a little bit to the standards groups. One of our core functions is to try and make sure that technology, when it comes out, is ready. So we do a lot of plug fests. So for instance, we'll get vendors together before stuff launches to make sure that when it launches, it just works. And the thing that we're doing, so we do education, so we'll do webinars, we'll go to shows and we'll put together multi-vendor demos. As you well know, getting a single vendor demo is pretty easy. You can always make sure it works. Getting it together with multiple vendors is much more interesting. So if I want to go to a show, seeing one with multiple people working together is a more interesting topic because people don't have the luxury of having brand new networks all the time. Our job really is to accelerate the adoption of Ethernet technology. As I said, part of that is working on plugfests, but part of it is explaining to people why they should care. So we're actually going to, I think you've seen my Voices of Ethernet series that we've started to come out with, which is really doing interviews with the original giants of the game. I think part of this is that people, while they don't need to know where it came from, they really want to. You want to understand the process.
Yeah.
And so getting some of these people who are originally involved and getting them on tape before they move on is really important. But we're also doing things like we'll do some webinars, right? We did one we're starting a series on Ethernet and OT because that's one of my interesting points. So we did one like this week. We'll have another one coming up in a month or so. So in general, the idea is to have information about Ethernet that people can consume in a way they can consume it when they need it.
That's great. Talking about history, I've got this here. This is like brings back a lot of pain for people who know what it is.
It's supposed to be yellow because then it would be fat yellow coax, which is what we always talk about.
I was wondering if you were going to say that. I only brought this piece here because it's got this connector. I've got a piece of yellow at the back there, which I can. But can you explain what this is, and then explain what this is? I could do it, but you're so close to Ethernet.
So what you have there is the fat yellow coax. So this is the original Ethernet that Metcalfe invented when they were at Xerox.
Yep.
It was Metcalfe and Dave Boggs. And by the way, so David Boggs is listed as the other inventor of Ethernet. He passed away last weekend.
Wow.
We'll actually have a Bob Metcalfe, who's the guy most people know, has actually written a memorial that we'll post. So they were basically working out at Xerox PARC, and if you think about it, Xerox PARC has been probably the biggest font of ideas and the biggest font of missed opportunities, right? Because between Ethernet and they invented the mouse, they invented a lot of things, they couldn't productize them. So the goal was they had a vision of basically a connected workplace, and so they wanted to have basically a computer on everyone's desk, and they wanted to hook them together. And I think the reason they originally claimed to start building Ethernet was to share laser printers. This was Bob and a few of his cohorts, and they took some ideas from the Aloha radio network, and they basically made a shared media. And the idea was that stuff would basically run down a corridor between offices, and you'd basically spike into it from each office. They originally started, I think, it was 2.9 or 3 point something megahertz. And the reason that is because it saved them a clock circuit on their board, right? Because they could use the clock off the backplane of the system they were on. Remember, this is the time when boards were yay big, right? And it was all discrete chips. And so development happened there, and then Metcalfe went off to found 3Com. And I think 3Com, was the granddaddy of Ethernet companies. And one of the things he told me, if I recall the story correct now, one of the things I read in a Ethernet 3Com history book, and I'll send you a link to it, was at one stage they got really excited because they'd invented CheapInternet, right? So CheapInternet's the other small one you got there. You want to wave that around again?
Yeah.
So CheapInternet was awesome because it was easier to put together. You could put things in the middle. Of course, what happened with it occasionally, like where I used to work, we'd basically have a loop of CheapInternet sitting on our desk. Yeah. And you could put new segments into it, which is awesome because it would work for my end, it would break someone else. Anyway, so they got all excited, and they invented CheapInternet because they thought this would be a much easier way to consume Ethernet, right? It would be just wonderful. So they got Steve Jobs, and they came into him and it's like, Steve, right, we've done the best thing, right? We've got this network that's much easier to use. You can replace your Apple Talk network. And apparently he looked at it and said, yeah, really? Why don't you put over the voice cable instead? And if you go down in time, that became 10BASE-T, and that's really where Ethernet took off. And one way to think about this, at least in the US, is that's when the Bell got broken up.
Yeah.
Because previous to that, the telephone company owned the wires in the wall.
Okay.
But when it got broken up, that became resource that was available. 10BASE-T Ethernet was built to run on the cabling that was in the walls.
And that what is that category 3? Is that right?
Yeah, it's Cat 3. All of a sudden, it was, we can build something and we can use what's there. We don't have to recable the building. So I'm going to make the argument that that's what really transformed Ethernet from a interesting sort of curiosity. Actually, 3Com was making a good business. It went from being something that you could deploy if you had to something almost anyone could deploy.
And that's because the telephone cables in the walls were now available for anyone to use, yeah?
They were there.
Yeah.
Now, there's a couple of other things that went to going to that model also made it a lot easier to debug. Right? Shared media stuff is fun, but it's hard to figure out where the problem is. As soon as we went to like a hubbed or switched model, it was much easier to track down. But the stuff was in the walls, right? I could upgrade without gutting a building.
So you're telling me Steve Jobs invented Ethernet?
I'm telling you that Steve Jobs made the comment to Bob Metcalfe and co. that this CheapInternet stuff was good, but he would really like to have it on the voice cabling. And so I would say he prompted what we think of Ethernet today.
That's amazing. I didn't realize
that. Most people think Ethernet.
Yeah.
They look at an RJ45 cable, right? An RJ45, and they think that's Ethernet.
Yeah.
In reality, there's all sorts of connections out there in the world. All of the high-speed optic stuff is, in a QSFP type model with an LC connector. But most people think of that RJ45 cable, and that's the category cable.
Yeah, this one, yeah.
And you'll know. So when you say RJ45, that's not actually an RJ45, right? It's actually an 8P8C connector.
Yeah.
But that was, I think, the first Ethernet that really went to where people were. because it was designed to make it easy to deploy. And if you think about it, Silicon Valley has a bad habit of coming out with things which are awesome but hard to deploy. So on one set of slides I have somewhere, I make the analogy between the network and the interstate highway system in the US.
Mm-hmm.
I'll get some of these numbers wrong, but it'll be close. So I think the interstate highway system will get started in like 56 or so, and they normally think they finished it in 49,000 miles of highway. Okay, nominally, so the lane width is 13 feet. Okay, so think about the Corvette from 56 and the Corvette from 2022. Very different cars, but they run that same infrastructure.
Yeah.
If I built the 2023 Corvette and it was 14 foot wide, where would I use it? Look, if you build a new city, it'll be awesome. So Silicon Valley tends to have let me go and build the shiniest, coolest thing. But technology is useless unless you can deploy it. I think that's the Australian in me coming out, right? Awesome, that's wonderful. How can I use this?
Exactly, but it's true.
I mean, if you want to get things done, right, figure out how the person you think wants it can consume it. I mean, like your business, right? Your business is a YouTube business now, or Udemy.
Yeah.
And you think a lot about exactly how that your subscribers can consume.
Yeah.
Right. Because coming up and saying, look, I'm David Bombal, I'm awesome, you should do lots of work to listen to me, right? That's just not practical.
Yeah, you're not going to have a business.
Figure out.
Yeah.
You start off with respect for your customers and figure out how they can consume.
Yeah.
And make it easy for them to consume. I think that's the way you get stuff done.
So Peter, I had to get some of this coax now, because this is like the yellow. What did you call it?
Fat yellow coax.
That's the yellow coax, the original stuff. Yeah. So what did they call it? Like a hose pipe type stuff, yeah?
Yeah, I mean look, you could. I don't think you could even tie someone up to it. It's just too stiff. I mean,
that's a nightmare.
The band rate that stuff is ginormous.
It's an absolute nightmare. Those stuff.
And so I've got to tell you, right? So you know the one you got in orange there, which has got the transceiver on it.
Yep.
They call those things vampire taps.
Yep.
Right, because you basically have to press them in, have to get the conductors. Now, what's interesting is if you take a look at this stuff, it's actually got markings like along it, which are the places you can insert it. Because you can't actually put them next to each other. It was interesting because you could add or remove devices without stopping the network. Yep. But the way you had to remove the devices is you basically poked a hole right through the cable.
Yeah, I'm glad I'm too young. I'm too young for that. Sorry, go on.
Too young for you? Sure.
Yeah, not that old, thanks. But for anyone who wants to see a working network with that stuff, I'll put a video below. I did create a video, and I'll create some more actually, showing like old technologies like 10base2. So go on.
You can make the argument that no one needs to know this stuff, but I think there is the old saying about those who ignore the lessons of history are doomed to repeat them. But I also think for lots of people, having more context of how things came together, you end up feeling more comfortable because going out and doing something where you know that one level down, you have no idea, that's a bad place to be. You want to be able to have context of at least a couple of levels down and back as to how we got here. Right? And I think that you don't have to have it, but it becomes much more easy to feel competent in your field. And for a bunch of the geeky people, they just enjoy it.
So that gets me to the point. So the reason we went from this, I mean, I found some really old videos of Bob Metcalf explaining this. And one of the reasons he didn't like the hub idea was what did he call it? A rat's nest of cables. So he liked the idea of like a long cable.
Yep.
But then I didn't know that. So Steve Jobs kind of said they should use the telephone cables. And that makes sense to use that. So originally we had, what is it? Cat3 cabling, 10 megabits per second, yeah? Sorry, go on.
If you think about that, so the way you tend to describe Apple is they had a maniacal focus on making technology usable. And so it actually sort of makes sense, right? You have the technology developers and then Jobs coming in and saying, that's very cool, but how could I consume it easier?
Exactly.
So it sort of fits together.
Just getting back, so we had just give us a bit of a history, Peter, because you've been working with this stuff and you're very close to it. We went from 10base5, this crazy big stuff. Then we went to 10base2, this like thin net, as it's called.
Cheaper-net.
Or cheaper-net.
Cheaper-net.
Cheaper-net, yep. Because it's obviously cheaper and easier to use.
Because it was cheaper.
Sorry, go on.
Because it was cheaper. I mean, yes, they often call it thin net, but cheaper-net was the often used term.
And I mean, the reason they did that is it's much easier to use. Obviously cheaper being a big thing. And then we went to the Steve Jobs comment. We went to this 10base type stuff. Is that right?
Yeah.
And the reason for doing that was because the cables were in the walls.
Because it was in the walls and you could use it. So after that, you start getting, I can't remember the ordering number, you start getting into the fiber world. And the fiber world was where you had to go longer. I don't think they ever did a 10 megabit fiber, but we did 100 megabit fiber and then a gigabit. The fiber advanced faster, because fiber is just a much better media. So the fiber is usually is a step or two beyond copper for a long time. But you take a look and, the numbers really took off in 100 megabit and then gigabit. Gigabit is the, 1000 base T is the huge seller and has always been. And of course, that relies on category 5E. So for a while, the cable categories were going up. We used to tend to say we can do new cables for every new building, for every new standard. And I think probably at that time, there was an awful lot of new construction going up. But when we went to go beyond gigabit on base T, the cabling companies, we defined category 6, and that wasn't good enough. So 10G base T, they actually needed a new cable type called category 6A. Now, the problem has been for a long time, there's very little out there in the world. A number of years ago, I think about 2014, the install base of category cabling was about 1.4 billion outlets, and 1.3 billion were category 5E and 6.
Okay.
So they couldn't run 10G base T. And I think we probably sort of got together around the time I was off doing the evangelization work for, what was then called N base T.
Yep.
Became 803BZ, which is 2.5 and 5G base T. It's like, why did we do those speeds in the middle? So partly we were sort of enabled because on the data center side, they'd just done 25 gig. And they'd done 25 gig because it really lined up with the SerDes speeds in PCIe. And that we could go and say, well, we don't need to do the by 10 thing. And so we took a look and we said, given all the infrastructure, how can we go forward beyond a gig? I think the initial driver really was where Wi-Fi was going.
Yeah.
But even behind that, if I go and talk to my friends out at Intel today, they will tell me that a Core i3 can fill a 2.5 gig link.
Okay, yeah, so makes sense, yeah.
We took the 10G base T technology and slowed it down so you could deploy it on what people had in the walls. Sort of the same deal, right? I need to go and find something that people can deploy. And I think that's sort of where I found my niche, because after that, we actually did 25 gig single mode. And it was the same thing. I wanted to define it so it will run on 10 gig. So if you have to test, right, and you're not sure it's going to work, that's a long deployment. If you are confident that if it ran 10 gig fiber, I can pull it out and I can run 25 gig on the same fiber without thinking about it, that's easy.
Yeah.
The sort of the same thing with the 2.5 and 5G base T. You can replace it, it's just going to work. On the rare condition it won't work, it'll basically go back to a gig worse off. So that becomes a pretty risk-free deployment that people don't have to think about too much. So again, if we want to succeed, we have to make our stuff easy to use.
So I heard you on another interview explaining this. So the idea is if the cabling isn't good enough, at 5 gig will then just negotiate speeds down, is that right?
Yep, that is correct. So that's the thing we actually defined in the N base T Alliance, and it's not rocket science, but it was a thing that was previously against the Ethernet religion. You just sort of have to make that work. And there's sort of been there've been some efforts around this in the conversion from 100 meg to gig, because I don't know if you recall, but 100 base T only actually uses 2 pairs.
Yeah. So
a whole lot of people have done what they call pair splitting. So on each end, they would basically split out 2 pairs, and they'd run effectively 2 links down the 4-pair cable. And that worked fine until you tried to upgrade to gigabit, and then it wouldn't work properly.
So just for everyone, so people who are not technical, so you can just go through the details. So 100 meg is 2 pairs, is that right? So 4 cables, yeah?
Yeah, so yeah. 100 base T actually took... So the category cable we think about is 4-pair cable. But 100 base T only actually used 2 pairs of it for the data. And when they first did PoE, they used the other 2 pairs. But gigabit,
power over Ethernet, just for everyone who knows, yeah.
Power over Ethernet.
Yeah. Sorry, go on.
The 1000 base T required all 4. So some people had basically they'd effectively run 2 links down a single piece of cable. And so later on, when they just tried to upgrade it, right, all hell broke loose, it wouldn't work.
Yeah, so this has got 8 cables in it. So then they would take 4 for one, 4 for the other. And obviously now with gig, you need all 8 cables.
Yeah.
Yeah, 4
and
pairs.
Of course, the guy who'd done the pair splitting, he was probably long gone by then.
Yeah, exactly.
But our goal with what we call redshift, I can't remember the name we gave it. So the goal basically was, if you think about, so when you do copper cabling, the standard thing they say is what they call a 6 around 1. There's a cable by itself. Well, if you put 6 cables around it, the guy in the middle is called the victim because he gets noise from everyone around him.
Okay.
You could well find, let's imagine that you had a big bundle of cable, maybe 24. You upgraded one of them to a higher speed and you tested it on the weekend when no one else is there, it would be perfect.
Yeah.
Come the weekday, right, when everyone else's lines are busy, right, the conditions could get worse. So the goal was to make sure if you couldn't keep a link up at 5 gig, you could drop back to 2.5. Can't keep up at 2.5, drop back to 1. So the goal is to make it as easy as possible to get the new service, but to guarantee the old service if it didn't work. The same thing, you've got to be able to offer the ability to adopt. And if you come in and say, look, I'm going to try this thing, if it doesn't work, nothing will work, no one can adopt that.
Yeah, that makes sense. I mean, so in today's world, are most devices gig or 100 meg? What are the end devices? You're involved in this stuff, so like kind of give us an image of the real world. What is it mostly gig on the end devices, or what do we got these days?
So at the minute, the vast majority is gig, right?
Yeah.
There's not much sale for 100 meg anymore, and mostly that's because the incremental cost is very small. I was talking to some friends at Intel. They're seeing a very strong adoption of 2.5 gig, partly in client type devices, and you'll see it in things like Thunderbolt docks, but also in a lot of embedded systems that are coming out, because the embedded guys tend to want to have like a 10-year lifestyle. So, speeds higher than 2.5, right? You see a lot of new access points. The Wi-Fi 6Es are coming out with maybe a 5 gig link. And beyond that, the heavy data things. So if you have someone who's doing heavy media editing or something similar, a 10 gig link is awesome. I think we're a few years away from the transition where 2.5 becomes the new one. That's clearly where we would like to take the market. Now, yes, it's true that lots of people don't need that, but when you do, it makes a big difference. Let's say it's in your business, right? How big are the video files you normally edit?
Oh, they're massive. 50 gigs, some of them.
Cool.
Individual file, yeah.
Cool. All right. So, and how long does that take to transfer across 1 gig versus 10 gig, right?
Exactly.
That's a material difference to how you do your work.
Exactly.
So in general, in a general enterprise network, there's a set of things which really benefit from going faster. I mean, in the home, it can be things like if you want to get rapid access to your NAS, or someone pointed out to me, right, in a lot of parts of the world, people can get internet links at more than a gig, and everyone wants their desktop to be faster than their internet link.
That's a good point. I mean, you can get 100, you can get a gig at home. So why you obviously want your internal network to be faster than that, but the vast majority is still gig or to desktops and laptops and stuff, isn't it?
Yeah, the vast majority is still gig. That's changing as companies like Intel or AMD move forward. You see a lot of 2.5 gig on the more high-end things or on the gaming desktops. It's going to become normal because the delta cost is low. And also for these guys, they used to end up offering 2 1 gig ports, right, to give a high bandwidth story.
Yeah.
But 2 1 gig ports is much harder to deal with because link aggregation is not that cool.
Yeah.
So a single 2.5 is just a better story for them. You have a big fat pipe, and it mostly never congests.
Peter, I don't want to put you on the spot, but you work for Cisco, so we're going to use Cisco devices for the next section. So people don't send me hate. This is going to be just using Cisco devices.
I can't talk very intelligently about Arubas or Junipers, so that's a good idea.
No, that's fine. So I mean, let's say I'm looking at like upgrading a network. Do you have any advice? Let's say I'm sort of new at this, but I need to upgrade like a small, medium business and then say a bigger business. What kind of speeds would you look at, like at the access layer where people connect, and then sort of, have you got sort of like general advice? I know it's very difficult, but general advice.
The question really becomes, what is your upgrade cycle and what's the chance you can get more money in the, okay. What do my users look like? What is my upgrade cycle? If I get it wrong, what is the possibility I can get more money? Let's say you're putting a building up, right? A pop-up building for 18 months. Put in the cheapest thing you can find. But if I asked you, for most companies, right, go back 7 to 8 years and look at how your company has changed. A lot. For most people, it's like a lot. All right, so look forward 7 years. Is the pace of change going to get lower? Probably not. So you're sort of doing a risk reward between spending more money now or potentially becoming the bottleneck for the company later. Now, I think of the world as being, there's Corolla, Camry, and Lexus, right? You don't build Lexus, but I think you want to be in the Camry sort of stage. Now, again, it depends on your customer base. It depends what you see coming. But in general, I wouldn't go the cheapest, because often that you get left at the things you can't do. Your mileage may vary depending on what you have. I mean, your key thing is to get a network that supports your business, how it can afford it. Only after that do you then say, well, how many years ahead do I want to be able to support it? In my brain, it's always let's say your refresh cycle is 7 years. You want to be able to say yes for 5 of them, right? And for the last 2, you say, yeah, I can't really support that. If after like an expensive upgrade 2 years later, you say, look, I can't help you with that, that's a bad place to be.
So using that as an example, let's say it's 7 years. What kind of speeds should I get at the connections for users? I mean, this is not you giving specific advice. It's like just general principles to think about.
I would be looking at 2.5 gig, and I would be pushing for the price delta between 1 and 2.5. So the price delta between 100 megabit and a gig is almost nothing.
Yep.
So no one should be putting in 100 meg. The price delta between a gig and 2.5 is larger than I'd like it to be.
Yep.
So if I was looking, for instance, at a cabinet, let's say there's 200 ports coming off the cabinet, right? I might say, well, I'll have 25 or 50 of them being 2.5 gig and the rest being 1. That would give me some leeway to adjust as it happened, and that would give me some flexibility. That's sort of where I would be thinking. So
that's down to the users, and then to like your core network. What kind of speeds are we looking at these days?
25. So traditionally, right, with 3-layer, right, gigabit down, 10 gigabit up, 40 gigabit beyond that.
Yeah.
right? So I'd say, well, you go 2.5, 25, and 100. Going forward in time, it may become 5, 50, and 200, or it could become 10, 100, and 400, right? It's a little bit hard to see going further out. I mean, there's been a pretty cool world where we go sort of the one lane, 4 lane story, right? Between 10 gig to 40, 25 to 100, etc. And I expect that to continue. Part of this really depends on how good we are on making sure we don't make people recable. So a lot of the higher speeds today are being done for the data center, in particular the web scale guys. They don't really have a fixed infrastructure problem because they'll just rip out everything. The enterprise is fundamentally different. When I started getting involved in a 25 gig standard, I wanted to bring it out of the data center where it had been defined, and it was defined for TwinAx and also for multi-mode at 100 meters of like OM7 or something. Okay, so that was no use at all for me.
No.
So first thing we did was we did the single mode standard. And as I said to you, what we just said is basically we set up so that if it ran 10 gig fiber, it would run 25 gig. And so we needed to do the same thing for 25 gig. That's mostly 300 to 400 meters of OM3 and OM4 was what 10 gig ran. So my company, we went and did basically an extended reach transceiver to make the same thing work. Because if you can adopt the new technology without changing that physical infrastructure, it's easy. If I have to wait for people to recable, it's just a very slow adoption cycle.
Yeah. So I think I've heard you say this in other.
Maybe the backup question. The backup question there is, if I'm doing cabling, what should I do?
Yeah. So let's ask that. So the first thing is like try and do as much as you can without changing the cabling. But let's say you had to cable, then what would you do? So let's ask you that question as well. Yeah.
On the access, I'll be running Cat6a to everywhere, and I'll be running 2 Cat6as to every access point. Why do I run 2 Cat6as? Well, part of the reason is that gives you a redundancy, something broke in the middle of the cable, but you're also going to drop it out there with a service loop. Okay, so let's say I have an access point some stage in the future which really goes above 10 gig. Firstly, that's actually a bit tricky because it would be like this, it would be yay big. But what you can do is, let's imagine you have a 5-meter service loop out there, right? I can then put 2 access points in 5 meters apart. So that's what I would be doing. So category 6A on the edge. In an ideal world, all of your fiber should be single mode because then you will not have an upgrade problem. People get worried about single mode because it's harder to put in and transceivers are harder. The cost of going back is enormous. If I was going to, if I had my druthers, I was doing it would be Cat 6A on the edge and single mode everywhere else.
That's interesting. Yeah, because I mean, like you just said, most people would say multi-mode fiber.
And if it's okay to go back and upgrade it, right? If you have it in a conduit, you can pull a new one. Awesome. But if not, if you think about it, so the case I made up was for 25 gig, right? The spec that came out of the DC for multi-mode was 100 meters of OM7. Okay, so let's say I want to adopt 25 gig in the campus, and it's that spec, right? How long is it going to take me to re-pull all of the fiber that goes from my wiring closet to my distribution?
Yeah, that's a good point. Yeah.
As an industry, we're doing better at trying to make it work on the old stuff, but it doesn't get any easier. So if I was doing new cabling, I would think that my cabling is a 30-year, 40-year asset, right? Your cabling, as far as you can, should be designed for the life of your building. Now, the trick is that people think of cabling as a cost, but you really think of that cable infrastructure as an asset. The cost of putting in a better asset is pretty low. The cost of replacing is enormous. If you're doing an 18-month pop-up, put in the cheapest thing you can. Otherwise, consider the life cycle of the asset.
It's always hard, though, because, I mean, it's like that whole thing, you don't know how long it's going to be, but I know where you're going with it. It's like if
everyone wants you to do it as cheap as possible. Right?
Exactly.
Yeah. Like, how can I get it cheapest? And there's always a problem between. I think of it this way. So imagine for a second you got a network architect for a company, and his boss comes up and says, "Great news! The new facility has been approved." It's like, whoa, go get me a network. It's like the first time I get a new network forever, right? Because mostly you have to work on other people's. So you go off and you spend 3 months, and you come back and you say, "Boss, I got the network for you. It sings, it dances, it's software defined, it's AI, it's got ML, everything." And he says, "That's wonderful. How much?"
Yep.
You say 15 million, right? And the blood drains out of his face.
Yep.
And he says, "How much?" 15 million. He says, "Could I get it cheaper?" It's like, "Sure, I could get it to you for 10. It's like, what? So at some stage, you have to be able to make the argument that the additional money is worthwhile, which means you have to understand what it is you're putting in, because you're asking the guy who signs the checks to go get extra money to make the guy who comes behind him look good. So I think this is where our business is actually built on trust. And the way I think about doing this sort of conversation is you have to build a cycle of trust all the way out from the user, way back to the technology producers. They have to trust that we're going to do mostly the right thing and look after them.
Yeah, no, that's great. I want to ask you some more philosophical stuff. You've been in this game for a long time. What advice would you give yourself if you were 18 or 22 years old? So if you were talking to your younger self, what advice would you give yourself?
Drink less beer.
I like that.
So I actually do a lot of mentoring of people, and I sort of ask them things like, think about where you are, think about your plans, etc. And I did none of that, right? I sort of had a very vague idea. So I guess look around fairly broadly, right? Listen to people who make sense, but try and find something for which you have an affinity. I think there's a lot of people probably going into software now because software is a cool career, you can make money, etc. But careers they're marathons, not sprints. So I think your ideal is somewhere where you have both talent and it gives you some satisfaction. So everyone today is going to have to know how to program to some extent. Doesn't mean everyone's going to be a hotshot programmer. Doesn't mean everyone is going to be going in and hacking into DoD.
Yeah.
But you have to understand how that works. You have to sort of figure out whether you're from the programming helping something else or something else helping programming. Not everyone's suited for every job. I would be a horrible UI designer. So, a long time ago, I figured out I wanted to be in the bowels of networking. So I've done everything from register bashing through running network management. Careers can't be that well planned. But I think you go through and you sort of have here's a set of things I'd like to do, and think about what you need for those things. So maybe you end up with a 3 or 5 year plan and say, well, if I wanted to go here, I would need to do these things now. And every couple of years you reevaluate the plan, and it can change because people change. The way I used to work before I had kids, right? I don't work the same now. Be flexible, but try and find something for which you get satisfaction. I don't think I'm not really sure that people really love their jobs, maybe you, but I think the important thing is to get satisfaction out of what you've done, right? To know if you look back and go, yeah, that was worth doing. So in my case, I got really lucky for that because when I went through a bunch of startups and small companies, and eventually I got to the stage, I got sick of building stuff that disappeared, right? Which is what happens in most startups and small companies. And so I moved to Cisco, and I came to the US in 2001 to join a startup. I moved to Cisco at the end of 2005. The 2001 self said, don't join the Borg, right? Because that's just not me. I don't want to be part of a big company. The 2005 self said, look, I've had enough of building stuff that disappeared.
Yeah.
So you take a look at this thing behind me, right? This is not a gold record because I can't sing. So this is a wafer from UADP or Doppler ASIC. So I got lucky enough to get involved in that program in mid-2006, and we shipped product in January 13. So that was the CAT 3850. Yeah. That's the predecessor of the Cat 9K. Now, I have my fingerprints all through that ASIC and all through that software architecture. And so for me, that's enormously satisfying because my stuff helps people do their work every day. I'm not the Ferrari or Formula One guy. I'm the Camrys and Corollas guy. Build stuff that everyone gets to use. What gives people satisfaction is different for all the people, right? So I think when you're young, go and take a look at various different people, talk to them about what they do and see what rings true for you. There is no one right path, right? There's a path that works for everyone and it can change on the way through.
I mean, people always ask me, should I do this or should I do that? And it's like, you got to do what's right for you.
We can be a little more useful, right? We can say, well, so if you wanted to actually make a lot of money at the minute, go and become a COBOL programmer, right? Because there's almost none of them left. And there's a huge amount of infrastructure, like the entire US internal revenue tax system runs on COBOL. Having programmed COBOL, right, I wouldn't want to do that. You have to take a look at where you think your skills and talents are and go and talk to other people and see where they match. So ideally, you find someone that pays pretty well. Money is not everything, and very few people get to the end of their life and say, I wish I'd worked more. So my view is you work to live, you don't live to work. Now being said that, we are in the fortunate position of being able to choose this, and there's lots of people who can't. But I think the ambition is to find something where your work supports the way you want to live.
I wanted to ask you about the ASIC business because that's what you've given me ASICs, and I've seen you do a lot of that. How do you get into that? If that's something of interest, how would you recommend someone get into that?
I'm not actually an ASIC guy, though I pretend to be one sometimes. I'm actually originally a software guy. People get into the ASIC business. They do an electrical engineering degree. Electronic engineering degree. And then you have to go and find someone who builds them. It's actually getting harder and harder because the ASIC business has got smaller, but there are people who want to do this. And so there's a certain set of skills you need. And I think often if you can get yourself into an internship at a company, that's a good path in. At the minute, it's sort of weird. So Silicon Valley is strange. It just is. Life might get a bit easier with all of our hybrid work. There's groups like, the Googles and the Apples of the world who offer a huge amount of money. There's groups like my company who don't offer so much. But I think, this sort of goes back to you have to figure out something that works for you. I think there's lots of opportunity. It just depends on what skills you have. That being said, I come from a Western culture with lots of money. So, the path from other parts of the world is harder. We know a lot of Indians and Chinese come through to America, from like the Africa. I don't know what that path looks like. It's probably closer to Europe. But I think you go to university to learn basics and to learn how to learn. And you make sure you're really solid on your basics, and then you are open to what's around and see where you can leverage it. That might sound a bit a bit soft, but that's the path, I think. Be aware, be interested, follow what's going on, get yourself involved in GitHub type things, find people who talk about it, get your basics solid, and then sort of be aware to what's around, right? Have a goal, and then talk to people and say, if I want to achieve this goal, what are my next few steps?
Do you see anything hot? I mean, apart from COBOL, what technology do you think someone should focus on? It's very broad, but like just things that you see, becoming in demand or that you see on the horizon.
There's enormous amounts of noise around anything with an AI or ML. There's enormous stuff around, container networking microservices. I can't say, but my guess is, there's an awful lot of people in that market, and there's going to be people who range from really, really good to not so good. So again, it goes down to you've got to find something which speaks to you, because spending all your time in a really hot industry doing stuff you hate. So remembering, we are much better off than people who dig roads. As much as possible, you want to find something which will provide for the life you need, right, and actually make you feel good. Yeah, I mean, I could potentially go and reskill and become a AI/ML programmer, but I'm not necessarily going to be better than anyone else. And it's not really what I'm interested in. So I tend to be the technology will change more than you think, right? If you think about the technologies I've changed. So when I started, it was all doing stuff which was on serial ports, right? And I was running, first program I got paid for was in college. It was on a system called an IBM System 34 with a language called RPG, which is a report program generator. And it was gross. It was an abominable language. And the next thing I went to go and do was up in a mine site, and we were running on a PC before PCs were standard, right? So there was lots of different DOSes floating around, and we ran a thing called RAT4, right, which was a preprocessor for Fortran to make it look like C. And so I've written in lots of languages, and technology has changed hugely. So you have to be ready to move. So ultimate specialization in one area is usually a bad plan. So I favor flexibility to roll with what happens, because you don't know what's coming around the corner.
And I agree with you. I mean, I had this conversation with others. You can't stick with the technology, because I don't know if you have this feeling, but I've always had this feeling as soon as I feel that I kind of know something, it changes.
Yeah. I mean, there are cases where being really competent in old technology can make you a lot of money, right? So we saw this around Y2K when all this old stuff got moved. We're seeing it today with people needing COBOL programmers. And so there is absolutely a market for people who are competent in old technologies. And so it's a bit like every now and again I go and see there's a raceway near me, Laguna Seca. And once a year they have their historics race meeting, right, where people basically come and they've got race cars from anywhere from like 1920 to 1980. Yep. And they restore them, they find out who they came from, they make them beautiful, they go drive them. So there's a market for that type of people, but that's not for everyone.
That's great, Peter. I really want to thank you, for sharing, technical stuff, but also like career stuff. Have you got any like final words, any advice before we wrap up?
I guess the advice is build a solid base and then go out and try things, and be prepared to change. Try and find people like a couple of layers up the career path from you and go ask them things. So my experience is most of the people in our business, if approached well, are more than happy to provide advice to people. And so you reach out, and it can be not every pair works. So some people I talk to, like just me and them don't gel, so I send them off somewhere else. But I think, that's build a base, look around, talk to people, and be prepared to change when it makes sense.
And Peter, would you like people to contact you on Twitter or those kind of places? Can you let us know, do you have social media people can follow you on?
Yeah, so Twitter and LinkedIn are probably my most active. I sort of go on and off Twitter a little bit, depending on whether I get busy, but that's certainly a place to find me. Twitter is a different way to speak than LinkedIn, so either of them is fine. I'm usually fairly responsive, but not always. If you happen to be around, I mean, I do a bunch of stuff with Ethernet Alliance. You're seeing some of that come out now. And I usually hang out at Cisco Live. So we'll be at Cisco Live in June.
Peter, I really want to thank you, for taking the time to share your knowledge and your expertise. Really appreciate it. Thanks.
So, David, it's been a pleasure. And we'll do it again anytime.
For everyone who's watching, if you've got questions, please put them below. I would like to do another call with Peter, perhaps do a little bit more deeper into the techie side. Peter, hope you're up for that.
Of course.
That's great, Peter. Thanks. Cheers.